Now that we know how to use cell statements, let's go back to the prune node by setting the edit flag on it. I'll click the X button to delete the existing path statements. But I'll keep the prune node disabled for now. If we use custom statements the same way we did in the last lesson, we will end up deleting the locations that we actually need. What we need to do is select these locations to remove using the prune node, which is the inverse of what we did before. So maybe you can pause the lesson now and think about how you will approach this. If you recall the last lesson, we started by selecting all the locations under assets, which is not always the right approach. Ideally, we should always look for a common pattern in the location name that we can use as a filter in our statements, like how we did when we selected all the locations ending with the name GRP. In this case, none of these locations have a common pattern. So we will have to start by selecting all the locations and then remove the ones we do not need. Let's add a custom statement. And like before, I will use the /* syntax to select all locations under assets. Next, add a custom statement, and again, I will select all the scene graph locations that has a pattern ending with the name GRP, except this time, I want to subtract the light group's location from the selection. So I will middle click and drag this location into the same statement and add the minus symbol between the two paths. From the drop-down menu, choose the difference mode. If you find and display the results of these two statements, we now have just two locations that we want to save from being deleted: the XGen location and the RenderCam location. Add another custom cell statement, and middle click and drag and drop both these locations into the custom cell statement. Now add a plus sign between them, and set the mode to difference. If you find and display the results now, you can see that we are left with only the locations we wanted to delete. Let's enable the prune node by pressing the D key while hovering over the node. And as you can see, we are now left with only the locations we need. But there is a problem here. If we rename the assets location back to what it was originally called, then this would break once again. Set the edit flag on the importomatic and select the hidden people asset to see its parameters. We will rename this to the hidden people. And if you expand this location, you can see that all the prune locations are back again. But since we're using custom cell statements, it is fairly easy to fix. Set the edit flag on the prune node, and wherever you see the name assets, replace it with the asterisk symbol. And as you can see, the prune node will work regardless of what the parent location is called. Let's go back to the importomatic and rename the location back to assets to keep everything organized. When we use the /* syntax to select all the child location under assets, it worked as expected. But scene graph hierarchies in a production scene is rarely this simple, and we will often have to use a different syntax in order to find the locations we want. Let's look at an example. Let's clear our cell scratchpad and create a new custom statement. I want to select all possible locations under the root location. So I will type the root location followed by the / symbol. What do you think will happen now? Let's find and display the results. It has only selected the world location, and this will become more clear if we collapse the world location. You can see that the world location is the only immediate child location of root. In order to recursively select child locations under root, we need to use a slightly different syntax. Let's go back to the cell scratchpad and add an additional / before the asterisk symbol. Find and display the results, and as you can see, we now have every single locations listed. Although keep in mind that what I have done here is very bad practice, and you should never start recursively searching for locations from the root location in a production scene, as this can easily create bottlenecks in your Katana script. Instead, you should try to narrow down the search to the nearest possible location. For example, let's expand the scene graph and look at the tree group location. Imagine that we need to select all the geometry locations under the tree group. Let's create a new custom statement in our cell scratchpad, and then middle click and drag the tree group into it. If you look at the geometry locations, you can see that there is a pattern here. All these locations end with the name shape, so I can add the double / syntax followed by the name shape. If you display the results, you can see that it has selected the locations we need, but in an efficient way because we only started the search from the tree group location. So always keep efficiency in mind when using custom cell statements. There are a lot more you can do with cell statements, and in fact, this has become one of the most important tools that I use to debug shots. I hope to cover this in a future course. In the next lesson, we will learn to use collections.